Next, let's look at output functions. There are two output functions in MATLAB. One is called which is display, and one is fprintf. Display is pretty straightforward. Fprintf is very versatile. So we're gonna discuss both of them here. Again, it's discussed at length in the tutorial. So I'm not gonna go over everything. You can read it. You can see how everything works. So display is very straightforward. Whatever you want to display, either a number or a string or whatever, you just put display, and then if you want to display a string, then it should be an apostrophe, and then my name is Masood Ijaz, for example. It's just going to display that my name is Masood Ijaz. And if you want to display a number, a vector, a matrix, or anything, just put display in parentheses the name of the variable in which the number is stored, or the matrix is stored, whatever, and then it's going to display that. So its display is very straightforward. Fprintf, on the other hand, is a little bit complicated, not a lot, but it is very versatile. And in fprintf, you can embed text basically in addition with the values. So for example, you can say the equation that I solved for x is equal to 5, y is equal to 7, z is equal to 8 produced a result of 235.7. That you can do with fprintf. That is, you can embed the values that you're calculating, the results that you're calculating, with the text that you want. Alright, what's the format? Fprintf, this is the format right here. Whatever text you want to write and whatever variables that you want to display. So this is not an easy way to understand. Let me just go to the example. So okay, let me go to the example, and then I'll come back to that. So look at this. We have value of a 23.456, b is 1 exponent 3 or 1000, and this is how you have to write fprintf value in the apostrophe. Value of a is %f. This %f is called specifiers, and these are specifiers that you can use in MATLAB. %f for floating point numbers, decimal numbers, %d for integers, %e for exponential number, %g, whichever is better, either exponential form or floating point form, is going to choose one, and %s is for strings. So %f and value of b is %e, because we know that b is an exponential function. And then you close the apostrophe, put a comma, and then write down the variable that you want to replace with the specifiers. So the first specifier will be replaced by a, and the second specifier %e will be replaced by b. \n means after it will print it, it's going to go to the new line, \n. So when you run this, it's going to show value of a is 23.46 and value of b is 1 exponent 3. So for example, if I want to write something like this, let's do another exercise. Let's say open another exercise, and let's see, this is my example, whatever example, a, whatever is that, example a. Let's say if I ask user to give me let's say we want to solve this equation, f of x, again f of x, let's say f of x, y, z equals 2x plus sine of z y plus let's see, x cosine of y divided by x y. Let's say we have to evaluate this equation for any value of x, y, and z. So let's say if I ask user, first of all, that x is equal to input, enter a vector with values of x, y, and z to evaluate okay, so we have to ask user this question, and then I'm gonna say I'm just gonna put a and cross it. Actually, this is going to be inside because this is the question I'm asking, and I'm gonna put a semicolon so it won't print it what I'm asking user. Okay, so now my x, y, and z user is going to give us a vector, and then that is going to come to x. So I'm going to go ahead and divide to distribute it. X is equal to x of 1, y is equal to x of 2, and z is equal to x of 3. And then I'm going to go ahead and write the equation down. F is equal to let me see. That's more like it. And then I'm gonna go ahead and do f is equal to 2x 2 times x plus sine of z times y. I'm assuming x, y, and z are single values here. They're not vectors. Plus x cosine y, so x times cosine of y, cosine of y, and this is divided by x and y, x times y. Okay, divided by x times y. And now if I want to print using fprintf, the result for f x comma y comma z for x equal percent 0.2f, and I'll let you know why I'm using 0.2. Y equals percent 0.2f, and 0.2, sorry, 0.2f, and z equal percent 0.2f is equal to percent 0.2f, and just gonna do backslash n, new line, and here I'm gonna enter what I'm planning to replace the 3 specifiers with, and I'm gonna replace them with the value of x, value of y, value of z, and value of f. And let's save this program. Example A, let's say. So when I run this, let's go to command window. Alright, let's see, 6, line 6, x equal x1, y equals, this colon should be semicolon. This colon should be semicolon because I'm dividing into 3 different things. Okay, so enter a vector with values x, y, and z to evaluate this. So let's say I'm gonna enter 1.3, 4.6, 8.9. So 1.3 is x, 4.6 is y, and 8.9 is z. And then it's going to calculate that, and it's going to print the result. The result for the fxyz equation for x is equal to 1.30, y is equal to 4.60, and z is equal to 8.90 is 2.48. So that's what percent 0.2f is, that it will basically write only 2 digit after the decimal place. And that's what you can do with 0.2. You can also do percent 4.2, 3.2, and it's going to have basically total 4 numbers, and 2 numbers is going to be after the decimal. So something like that. Well, that's what it means, 0.2. You don't really have to use it. You can just use %f. You don't have to use percent 0.2 or 0.3 or 5.2. Just use %f, %e, %d, whichever, because you're just starting to do this, and that's going to be fine. So this is how you're going to use a specifier and fprintf to print the result. Go over example 7, and exercise 8 is one of the exercises that you have to do. So in this exercise, basically you are asking user to give some values of resistors as a vector. So your question is going to be enter the values of resistor as a vector, and user is going to enter as many values of resistor as user wants. Don't restrict user to have only 2 or 3 values. And then you have to calculate the series resistance and parallel resistance equivalent through these formulas that you see. So for series resistance, all of the sum of resistors will be equal to the series equivalent. And for parallel, first you're gonna take inverse of all the resistors, add them together, and then divide that sum by 1. So actually I gave away the hint as how you're gonna do that. And then you're gonna go ahead and use fprintf and write this, and then embed the value of series and parallel over here. Where x is, that's going to be the series value, and where y is, that's going to be the parallel value. So you're going to say if all the resistors are connected in series, equivalent resistor will be 52, let's say. And if all the resistors are connected in parallel, equivalent resistor will be 3.5. So x will be replaced by R equivalent for series, and y will be replaced by R equivalent for parallel. There's a hint over here. The MATLAB function sum will be really helpful for you in this one. Think about it, how you're going to use sum to calculate. This is pretty straightforward, sum of the vector. Think about how you're going to use sum to calculate this. Exercise 9 is the last exercise for the homework next week. And exercise 9 basically is the same exercise in which you are calculating the quadratic equation, roots of the quadratic equation, as you did earlier in one of the exercises. The only difference over here is you have to give the output in this form. So basically you're asking user to enter the coefficients of the quadratic equation as a vector, and then when you calculate the quadratic equation, then your result should be, your answer should be roots of the quadratic equation. You're going to write down the quadratic equation. Let's say I'm entering 1, 5, 10, so 1x squared plus 5x plus 10 are, now there are 2 complex conjugate roots for this quadratic equation. Negative 2.50 plus j 1.94, negative 2.50 minus j 1.94. So you're going to be using the specifiers, fprintf statement, and a specifier here, a specifier here, over here, a specifier to print one root, and another specifier to print the other root. Now here's the thing. You cannot use a single specifier to print a complex number. So think about it, how you're going to print this complex number, and I'll give you a hint. One way is to convert the complex number into a string, and there is a function in MATLAB which is called num2string, num2str, that will convert any number into a string, and then you can print using the string specifier each complex number. The second trick is going to be that basically divide the real part and the imaginary part of the complex number, extract it, not divide, sorry, extract the real and imaginary part using the functions real and imag, imag, and then use toSpecifier to print this, and just write down plus j and print this, and then print this, write down negative j, print this. The only thing is, make sure it should not spell out negative 2.50 minus j minus 1.94, because the second root is going to be negative. So think about how you can, there's a, I mean the output is given here for this. Think about how you can do that. It's not very hard, it's pretty easy. I told you how to do it 2 ways: either convert it into a string and use a string specifier, or use toSpecifier and then print out the real value and imaginary value separately.